Hello there. So today we are going to go through a couple of examples to continue our review of exponential functions and the exponent rules or laws of exponents. So what I'm going to do is I'm going to go through a couple of examples of each topic, and then I will show you some homework problems that you can do right in your notebook. Okay, just try and save paper. So I will show you the homework problems as soon as I'm done with the examples. Alrighty, so let's go ahead and get started. So I have two examples for exponential functions. So this first one says, tickets for a big concert first went on sale 3 weeks ago for $60. This week, people are charging $100. Write an equation that represents the cost of the tickets, W weeks, we're going to use X just to remain consistent, X weeks from the time they went on sale. Assume that they continue to increase in the same way. Okay, so we need to figure out what our points are going to be, right? What our coordinates are going to be for our X and Y. Because remember, we want to write the equation in that form. Okay, so if I look here, it says they first went on sale 3 weeks ago for $60. So that tells me that the original cost was $60. This week, people are charging $100. Well, that's 3 weeks afterwards, right? So after 3 weeks, they're $100. That's where the points come from. Okay, now I'm going to put those points into the equations. So 100 equals AB cubed, and then 60 equals AB to the 0. And then we divide. So if you go 100 divided by 60, you get 1.6 repeating. So for this, I think we will round to 1.67. The A's become a giant 1, and then you subtract when you divide with exponents. So 3 minus 0 is 3. So now I'm going to take the cube root. So I'm going to go to my math menu, arrow down to the fourth option there, cube root, and I'm going to go of the answer. So about 1.86. 1.186, excuse me. Okay, so that's the B value. Now we already know the A value. Remember, the A value is when the X is 0. This is your A value, right? And you can see that here because before I cross this off, like this would become a 1. And so then your A would be equal 60, okay? So our A value is 60. Our B value is 1.186. So then our final equation, 0.186 to the X. There we go. And that's as far as we had to go. We just had to write the equation for that one. Okay. Next example, it says, when rabbits were first brought to Australia, they had no natural enemies. There were about 80,000 rabbits in 1866. 2 years later, in 1868, the population had grown to over 2,400,000. It's a lot of rabbits. Okay, so the first task is to write an exponential equation for the number of rabbits T years after 1866. Okay, well, we're going to pull our points, quote unquote points, from this information. Now, I don't want to include all of these zeros, so I'm going to say that originally they were at 80,000, knowing that this is in thousands, right? And then in 1968, 2 years later, they were at, if I cross off like the 1,000 part of it, 2,400, right? So again, I just took the 3 zeros off of there just so I wouldn't have to write so many zeros. Okay, so I'm going to make my equation. So 2,400 equals AB squared, and then 80 equals AB to the 0. Okay. Well, the nice thing is that these divide real nice. 2,400 divided by 800 is 30. This becomes a 1. 2 minus 0 is 2. So now I'm going to go square root of 30. 5.7. So we'll go 5.48. How about? So B is 5.48. Again, we know the A value because we have that 0, like the intercept there. So now when we write our equation, Y equals, I'm going to go 80,000. I'm going to put those zeros back in there for my equation. 5.48, and it said t. Probably just to represent time, like in years. Okay. Now look at part B. It says, how many rabbits do you predict were present in 1871? Okay, well, this equation represents the number of rabbits in years after 1866. So between 1866 and 1871, there were 5 years. Okay, so I'm going to plug that into my equation. 80,000, 5.48 raised to the 5th. So 80. Checking all my zeros in there. 5.48 raised to the 5th. Holy moly, that's a lot of rabbits. Okay, where are my camels going to go? Okay, so here it is roughly 395,360,046. I'm not going to put that 0.8 of a rabbit. That's a bit gross. Not rabbit. Rabbit. Goodness gracious. Because 0.8 of a rabbit, I don't know like what part's missing. I don't know. Okay, there you go. So now the homework problems, if you can see them on here, great. You can just pause this and then just do them from here. Otherwise, after this video is completely done, you can go into back into the module and you'll see I have them in there as well. And again, just do them in your notebook just to save paper, okay? Because I didn't want to run a ton of copies and all that. All right, so that is, these are your first 2 homework problems for this lesson. All right, next lesson, or next topic, excuse me, laws of exponents. So I put some more complicated ones on here. I figure we already reviewed these last time, so let's up our game a little bit. All right, so we'll jump right in. So these are just going to simplify the following. Alrighty, so in here I have x to the negative 2 times x to the negative 3, and then all raised to the 4th. I'm going to go ahead and simplify inside here. So I can add these together to get x to the negative 5th. And then when I raise that power to a power, I multiply. So x to the negative 20. But then again, you don't want to leave negative exponents. So x to the 20, or 1 over x to the 20, excuse me. That's our final answer. Okay. All right, next one. I'm going to simplify this first, and then I'll go ahead and combine this way. So this becomes x to the negative 12 times 2x to the 4th. Okay, well, there's nothing I can really combine that 2 with, so leave it there. But then I have a negative 12 and a 4, so that gives me a negative 8. But again, I don't want to leave a negative exponent. So that x has a negative on it, so the 2 stays right where it is. The x becomes the denominator. So 2 over x to the 8th is the final answer there. All right, next one. Again, I'm going to distribute this in here. So this becomes 4v squared now times 2v squared. So I can multiply the 4 and the 2 in the front to get 8. And then v squared and v squared, v to the 4th. There we are. So far, so good. Whew, get a load of this one. Wow. Just focus on the numerator. Ignore that denominator for a second, okay? Oh, well, this part is just like these up here, right? I can just combine. So 2 times 4 times 3. Well, 2 times 4 is 8 times 3 is 24. So 24, I'm just going to rewrite this down here. We'll come back to this guy. All right. X squared and x squared is x to the 4th. 1 more x, that would be an x to the 5th. And then y to the 4th and y to the 4th is y to the 8th. Okay. Now we will simplify up and down. Okay, so 24 divided by 3, that's 8. 5 minus negative 3 is like 5 plus 3. So I get an x to the 8th here. 8 minus 2, 6. Here we are. Okay, next one. This one we're going to ignore the numerator for a second. Let's figure this out. So 2 times 4 is 8. X to the negative 1 and x squared. Well, negative 1 plus 2, isn't that just 1? So x to the 1st. And then y. Okay, let me rewrite this on top. 3x squared. Okay, now again, we can simplify up and down. Well, 3/8, that doesn't change anything. I can't reduce that at all. X squared over x to the 1st, that's just an x to the 1st, or just x. Same thing here. We end up with y. Now, if you want to rewrite this as 3/8 and then just put x and y over there, that's fine. Otherwise, they belong in the numerator with that 3. Either way is fine. Okay, look at this. We have a 0 exponent here, right? Okay, so that one one's out, right? So now this tells me this goes in the denominator. Okay, this stays right where it is. So 2yx cubed over 2, this is gone, cubed. Okay. Again, let's just focus on that denominator for a second. So I get 8y to the 6th, and then I have a 2yx cubed. Well, I can reduce here, right? So I get 1/4 y over y to the 6th. Well, 1 minus 6 is -5, so negative tells me it stays in the denominator. And then I have an x cubed. So it looks like 1x cubed or just x cubed over 4y to the 5th. All right, almost there. So now, if I look at my numerator first, it looks like all I have to do is distribute that cubed in there. So 8x to the 9th, z to the 6th over, I can combine these. 3 and -4 is -1. 4, oh, I can't combine that with anything. 4. And then z squared and z cubed, z to the 5th. Alrighty. 8, I can't do anything with. 9 minus -1 is 10. 6 minus 5, 1. And then that y just hangs out. Doesn't combine with anything. Doesn't have any friends, apparently. Okay, last one. This one looks really complicated, right? Like, holy cow, there's negatives. There's all these letters, everything else. But look, bam. That whole thing is just 1. Okay, so we get 1 over 2h to the -3, j to the 4, k to the -2. Oops, that's a -4. Negative. Well, it looks like the 2 stays right where it is, but then all of these just get flipped up to the top, right? So we have h cubed, j to the 4th, k squared, all over 2. All right. Excellent. So these are the 6. So you have a total of 8 problems. That's nothing you can't handle. So you have the 2 exponential functions, and now you have 6 exponent rules. Okay. So again, just do these in your notebook. I will check them tomorrow when I come around and check homework. Alrighty. That's it. Have a great day. I'll see you all tomorrow.